Alright, so in this video I wanted to make a tutorial for doing a compiler for a really simple language, and my idea for this language is to have something really basic, like for example being able to have some if statements. That would be important because to have during complete programming language you kind of need the ifs and at least some go to instruction. So yeah, I'm planning to have like if statements and go to instructions. This will basically ensure that you can make for loops, simulate having functions and stuff like that. Then I want to have some way of doing input and output, right? And I think I'll have some keywords for that. I think I'll have something like, well, you can have, let's say this is the program that we are going to write, and you can say something like a is equal to input, right? So this will basically assign to a something that you can input. And to make things even easier, I'm thinking that we can have all the variables be integers. So this just trying to make sure that we can finish this in a small amount of time, so that you can gain as much information as you can from this video. So yeah. Okay, and as we saw, variables are gonna be just like characters, and we can also have like literals and stuff, right? So something like this. Then the next thing would be to make expressions, like arithmetic expressions, a bit easier, because if you can have stuff like this and also parentheses, only this thing by itself took me, when I did a cool compiler, like 2 or 3 hours to implement the entire thing. So I think I want to keep it simple and allow only like 2 term operations, right? And the idea is that this can easily be extended. If you want to practice doing that, you can easily do it. And then we should also have like relational operations, just because we have if statements, right? And we can have like an if and do something like this, and then go to, and what I think I want the labels to look like is going to be something like this, like label 1 or something, just to have some character in front of the label that indicates that it's a label, right? So and then we'll have like label 1 here, and the idea is that if the if is going to be true, then you go here. But the if statement can do also other stuff. For example, it can have any instruction here, so you can also have like a is equal to 1, right? So something like this. Okay, so this is basically the kind of the syntax of the language. I still think it's a bit too complicated, but maybe it's gonna be doable to finish it pretty quickly. So to make things a bit easier for me, I'll use C, right? Because I think that C is the easiest language to translate between other languages. So if you want to use Rust or Zig, probably you can look at the C code and figure out how to do it in those languages. But if I were to implement it in Rust, I think it's a bit harder to translate to other languages. And the reason why I'm not going with Zig is because I'm like still completely new to Zig, so I'd prefer to do it in C. So I feel like the easiest thing to do first is to have like an example file that we are going to use, so like an example program, right? So example, and let's make it txt file, I don't know. So we can have something like a is equal to input, and then I don't know, like let's say that we want to print all the numbers from 0 to input or something, right? So we are going to have an I, which is 0, then like label, maybe output I, right? Like this is how we should output numbers. Then an if statement, if I is less than A, then go to label, and otherwise, you know, it would stop. And I think that we also need, let's call this one n. I think that we also need to do I plus 1 or something. I is equal to I plus 1. So I feel like this shouldn't be, you know, the tokenization is gonna be pretty simple, I would assume. But yeah, this is how I would imagine something really basic to look like. So yeah, let's see what we can do about it. So I think the first thing is to define some kind of enum, right? And this would be like token kind, let's say. And now we just have to think what kind of tokens do we have. So obviously we are gonna have identifiers, right, like variables. Then we also have a token for the, let's do the keywords after identifiers. So I think input is one keyword, output is the other one, go to obviously, if, then. I think these are all the keywords. So we can also add, for example, we can also add the label, which is going to be like labels. Okay, so these are some things, and maybe int, which is going to be like the literal int. And I think I'm going to do just plus and less than, or also equal, or I guess a sign, but equal, plus, less, less than, sure, why not? So feel like these are all the possible tokens that we can have in the language, and we don't have like a colon, right? Colon is not necessarily a token because the entire thing is a token, so colon plus the text is a token. You know, that's another thing to keep in mind. Okay, so yeah, we have the token kinds. Now what I would do is maybe have a function that you know, takes like I guess show token or something. So it should be something like const char pointer show token, and it's gonna get in a token kind. So let's do a quick switch on kind, and if we have case ident, we do ident, or I guess we return it, right? Okay, if we have case, actually let me just copy these things, it's gonna be easier. And now I can say case, okay, return label, I think, I mean, you know, I'll just okay, so we have all the I guess, you know, if I format, this is how it makes it look like. So we have all the tokens, right? So the next thing would be to implement the actual Lexer, right? So we'll build the same data structure as usual because I feel like that's the best way to do it. So yeah, basically we'll have the struct Lexer, and we're gonna have the buffer that we're gonna read, the buffer length, the position, the read position, and the current character. And I think I forgot one thing, and that is the invalid token kind. So if we have an error, let's say, so let's add that in invalid. So yeah, that's the last token kind. So we have the Lexer data structure, right? And you know, if we take a look at the cool compiler, I have some util functions. For example, being able to pick one character, being able to read one character, skipping white spaces, and so on. I'm not sure if I want to just copy paste them, but you know, honestly, I think, you know, if you have a project existing, like, what's the point of writing it every time? So let's just go through why I needed this function. So this one just looks at the current read position and tells you what character is there. So this is usually needed in case we have, let's say, more complex operations. For example, if we would add the equal, then we need a way to differentiate between this equal and you know, the other one. But in this case, I don't think it's required. So yeah, probably will not even use peak, but let's just keep it because I think read character depends on it, so that's maybe one reason. And read character, the idea with this data structure is that we are going to have a buffer, and we want to advance each time we read a character, right? And this ch is just a way to keep the current position in the character, right? So yeah, basically the idea is read character just advances the buffer. So this is more or less an iterator over a character array, and this function is next, and this, I don't think peak is a thing, but probably if peak is a thing, then this is peak. So we have implemented next and peak basically for an iterator. That's the idea for these two functions. Then, you know, really util function would be being able to skip white spaces, because I mean the language is gonna have some white spaces, right? And skipping white spaces is gonna be useful. So skipping white spaces, what we need to do is read char until we find something that is not white space. And I think for is space I need string.h. Oh, and yeah, ds implementation. Let's just do it like that. This one's strange. I thought is space. Oh, is in C type. Interesting. Then string.h is useless, but let's just skip it. So we have skip white spaces, which is gonna, you know, remove all the white spaces. We don't have comments, so let's ignore the comments part. But you know, if you want to do comments, then that's another thing. Okay, let's do Lexer init. So Lexer init, the idea is that we want to put to initialize the iterator with a buffer. So again, this one is just being able to copy paste it, pretty nice. And one thing is you have to make sure that we read the first character, so not forget to read the first character, otherwise it's gonna be 0 and we'll think that we finished. Okay, let's not worry about strings in this one. Like, I think strings would be way too difficult to implement. Like, I think strings alone took me like, again, like 2 hours or something, so that's rough. Okay, so being able to read the next token, right? So we have this function which reads a single character, but we want to upgrade this thing to being able to read an entire token, right? And I guess what is a token? We have to define that. So let's make it simple, I guess. So struct token. Let's just have the token kind, right? And I guess a char pointer value or something. Oh, but I don't remember declaration does not declare anything. Was this not? Oh, kind. Yeah. So we have the token kind, basically a token, you know, in again in Rust you'd be able to say here value like this, so you don't even need the structure. But because we use C, we actually need this structure that is gonna wrap around the token kind. So, you know, value. Now you can do even more like interesting stuff, like adding the row and column here, but I feel like that's not necessarily what we care about, right? So we are just gonna keep the value, and the value is gonna be required for identifiers, labels, and integers. The other stuff can exist without the value, so that's one thing. Okay, so when we try to get the next token, the first thing that we need to do is to read a character, or I guess, you know, skip white spaces. That also makes sense, right? We want to skip the white spaces. Let's just get that out of the way. So, you know, get rid of all the spaces, all the new lines, and so on. Then after we manage to you know, skip all the white spaces, we are clearly on some character, so we might have to do a switch on the Lexer character, right? We have to do a switch like this. But I mean, here I did like an if else. Honestly, like doing if else might be better, just because, yeah, I mean, in C you don't really have that pattern matching power of Rust, for example, so doing if else's might be easier. But I wanted to say that here I was also keeping the position, so yeah, that's the part where I was doing the position for the tokens, if you care about that, you know. So if this character is equal to end of file, right? Oh, and another token that I forgot is end. But honestly, when I did the cool compiler, the end token wasn't even that important, in my opinion. Like, everything would have worked even without the end, but it is, you know, sure, why not? Because when I made the implementation of the Lexer, I took inspiration from like the how to write an interpreter in Golang or something like that from Thorsten Ball, and yeah, I mean, that was like, haven't even read the entire book, like just the first chapter of doing Lexer, and I was like, oh, let's try to do it. And yeah, mainly because the book was about interpreters and I wanted to do a compiler, so at some point it would become useless, although, you know, building an interpreter is still interesting. So, but yeah, whatever, let's have this copied just to be ready. So here I called it literal, but I would call it value and kind. Right, so this is how we manage this thing. Then on the else if case, if we have, let's say, like what characters can we check other than that? I mean, you know, probably, I mean, brackets and so on, it's not really that big of a deal, but like less than, for example, or I guess the first one is equal, so the first important one. So Lexer read char, and we do Lexer read char because we want to skip it. Like right now we have the head position on the equal sign. We know it's an equal sign, so we skip it with read char. Right, we do next basically on the iterator, and then we are gonna return equal. Right, and we do the same thing. So let me just copy paste it for let's say plus and less than. So this is gonna be plus, this is gonna be less than, right? So this is how we do symbols: equal, plus, less than. And now the interesting part is gonna be these things. Well, integer is gonna be easy, label is also gonna be easy. So let's see. Oops. So if the character is gonna be like colon, we are gonna need to read until end basically, right? And that's gonna be a label. Then the other option is we find a number, so then we have an int, and I think I did that like is digit, right? That's the way to do it, right? Again, read until, basically until new, well, we should read until we find something that's not a digit. That's right. And else if it's I guess we don't care if it's uppercase, we care more about if it's alphanumeric, alnum. Oh, so if it's alphanumeric or underscore, let's say. And since we already have this is digit check here, we know that this starts with letter or underscore. Well, I mean, I guess, yeah, you know, starts with letter or underscore. That's a identifier. And on the else case, like if you are not able to read anything, then it's gonna be an illegal token. And what you have to make sure is that you still call to next, because even if it's an illegal token, you want to skip it. So illegal, what did I call it? Invalid, I guess. You know, whatever, invalid token. And I'm not sure, but here I think I want to put, maybe I'll use slice, right? Like this, and like, so buffer plus position. Well, I guess, you know, it's pause, but I have to do it here, and I can just take it. So this is gonna give us the invalid character. I'll call it value, but it's like this. Yeah, curious. I mean, you know, we haven't done returns here, so obviously it's gonna say that. So yeah, I mean, sure, we'll see how we can do these things, but yeah. So yeah, let's see how we are gonna implement this. All right, so okay, Right, so the label is the first one. This one shouldn't be that complicated, so I'm just gonna take this slice, right? Okay. All right, so we have like the buffer plus position. We have basically the same thing as we did here, right? But now the length is gonna be 0 for some reason, and when we encounter like a character, and I think I want to make the labels alphanumeric and underscore, right? No, so maybe like an explanation of what string slice is. It's basically a pointer to a string and the length of that slice. So if we start at buffer plus position with length 0, we don't have anything, but as we increase the length, we take more and more characters. But you have to pay attention, because this thing is like this data structure, it's part of the SDH. It's just a reference. So here we increase the length, but to get an actual string we have to call to like string size to owned, I think I called it. So I select value, we have this function which takes in this kind of slice and gives you back like a value. So it's like the literal itself. So I don't think I care about the fact that we have a colon in the name, but maybe we can keep it, why not? It's part of the thing. But if we want to skip it, I can do something like this. So this skips the colon. So now the slice, or I guess the label, is gonna be without the colon, which I think it makes more sense. So let me just take this thing, and here we are gonna return label with value, right? So this is gonna give us the labels, right? And yeah, I think it's pretty straightforward with Lexer read char and so on. So okay, so the next one is reading digits, right? So I think I still want to use a slice, and then instead of this thing I'm gonna do is digit, like this, and here I need to say int. So for this one we don't want to skip the first character, because the first character is gonna be another digit, so we don't want to skip that. And then for the other stuff, so for string things, I want to have another slice. I want to convert it to a value, but this time I want to have like a mapping, right? So I don't remember what I used in my initial implementation. I think I probably used string compare or something, but I mean with a function, but it's like, yeah, with string compare. So I would probably just do everything in this else if statement. So let's see what tokens we have. So we have identifiers, right? We have the input keyword, output, goto, if, and then. So these are all the keywords that we have. So let's go right here, and let's do something like if. So at this point we basically the same thing. Inside of value we have the entire string that we just read, so we can just string compare it, string compare value, and let's say we compare it with input, right? So if this thing is 0, then we can return struct token, the kind is gonna be input, and value is gonna be value, but we don't care about the value, I guess. So I'll do it null, right? Then else if. I think it's gonna be easier if I just use copy paste like this. So the next one is output. Right, so like this. Another one is go to. Then we have if, and then. Right, and then on the else case, the last possible scenario is that we have an identifier. So kind is going to be identifier, and for this one we need to keep the value because the value is the variable name. So this would be the entire tokenizer, right? It's pretty small and it should do the job. So what I think I did in my cool implementation is that I had this Lexer tokenize thing. So Lexer tokenize function, which was returning or initializing a dynamic array of so I guess let's do it like this. I don't know how I copy that. So int Lexer tokenize. I don't know why I want to keep the same name, but whatever. So let's do buffer, and you know, we'll need to call to initialize. So buffer length, right? Makes sense to have buffer length. Buffer length and ds dynamic array tokens. So basically this ds dynamic array is gonna be the list of tokens that we are gonna, you know, tokenize. So the first thing that we need to do is initialize the Lexer. I'm not gonna do error handling, to be honest. So initialize the Lexer. Let's call this one length. Alright, and the idea is that now we want to call to Lexer next token until we find end. That's the main idea. So, you know, we can have a token and then do a do while, I guess. That's usually the best, or I guess the easiest way to do it. So we have the token, we call to next token. I said I don't care about the position, and yeah, I think ds panic, and let's not care about that. Maybe it could be even a void function if I don't care about, you know, the things, but let's just keep it like that. So the next thing is to define a dynamic array. So dynamic array of tokens, right? And I need dynamic array init. I need to initialize it. So I'll pass a reference to tokens. Honestly, I don't remember the size, like what it should be. I think I can even say 1. Oh, item size, I'm sorry. Struct, oh, size of struct token. Alright, so we are gonna store tokens inside of this thing. So we initialize that and we call to Lexer tokenize. So obviously the buffer is buffer, length of the buffer is strlen buffer, actually this thing should return size, so length. Let's use length, and here we pass in the tokens. Okay, and I guess show token, show token kind, but show token, so let's implement also char, I guess const you know, it's easier to just say void print token, right? And oh, I forgot about talk. And then let's do something like const char pointer kind is gonna be show token kind, right? And we can do something like if talk dot value is not equal to null, then we can do a print. Oh, actually let's do a printf %s kind, and here let's do printf, and let's do the value in parentheses, so like this, talk dot value, and then printf a new line. So that's how we should print tokens. So now for, I don't really remember this dynamic array, tokens dot count maybe. Feels a bit strange. I don't remember how I was iterating over these things, but whatever. So struct token tok, this dynamic array get, and here we need to pass in the tokens array like that. Index is I, and the address to tok. Right. I mean, this could be an unsigned. I don't see a problem. And then print token tok. Right, so let's try to GCC the thing and find it. Oh, yeah, because ds.h, I forgot to do one thing in this, so we need to define IO implementation. I forgot about that. Okay, so if we cut this thing and pipe it into main, for some reason it was stuck. Let me just do a printf here, see what like %c, what LCH is. Maybe I forgot oh, okay, it means that I forgot to do a read char somewhere. Lexer read char. So it's pretty strange because oh yeah, oh shit, here it needs to be the same while loop. I don't know why I didn't So it complains that the index is out of bounds, right? Damn, it was so fast. Huh. But I'm a bit curious. How did that happen though? Because I said here, like, if it's end of file, we do end. Oh, maybe, maybe the length is not right. But I remember, oops, I remember like the length, so yeah, it's like 68, so it shouldn't. So what? Okay, like this one tokenizes it, right? Not sure why it starts with 68, but wait, what? That's really strange. Why does it start with 6? Oh, I'm stupid. I showed the length. But yeah, I mean, it looks good, right? So that's one. Oh, wait, no. Printf. Let me just double check the tokens count. Twenty tokens. That's a bit strange. I'm not sure what the mistake is. Like it keeps running crazy. Oh my god, I forgot about eyes less than. Okay, so we get identifier equal input, another one, and yeah, like, right, we see all the tokens. So obviously this would be the tokenizer done, which, you know, is the first stage of the compiler, and I think the next stage clearly should be the parser. So let's try to go to that one. So if we take a look at the readme, I think I want to build this some kind of structure like this, like some kind of AST. So I think I want all the, like, a program to be a list of instructions, right? So pretty much that's how it looks like. You have assignments, labels, output, another assignment, and then ifs. So that's what I think I want to have. So here I guess I forgot about label, but yeah, something like that. So yeah, this is what I think we want to have. So a program is going to be like a list of instructions. I just want to remember how I did it for my other project, just to recall. So still had like expression node, probably I'll have something like program node. Yeah. So again, it's gonna be similar but not quite. So we should probably have like a structure instruction. Let's call it node because it's in an abstract syntax tree, so it's gonna be, you know, the AST. Right, so the instruction node, right, should be like here. Like this one was a list of classes, but in our case it's just gonna be a list. Oh, I meant the program node, right? So struct program node is gonna be, well, I mean, I can just use that. So it's gonna be a list of instructions, right? And I don't really care about file name and stuff, it's just that. And I guess the instruction is gonna be similar to expression. So it should have like expression kind, right? So we'll have like instruction kind, and then honestly I really like the union thing. It worked fine for me, pretty decent, I might add. Okay, so here I can say kind, right? Why not? And then we can have an enum instruction kind, and I guess the instructions that we are gonna have are assign. So let's say assign instruction if, instruction go to, instruction output, and I think instruction label. Alright, so now we have all of them. Alright, so an assignment, I guess I can just add it here. Maybe it's gonna make it a bit easier to see. So yeah, interesting, we have a variable and then equal to an expression. Although don't really, I mean, you know, expressions, whatever. Alright, so would be similar to the assignment from here, which is pretty funny. Right, so okay, let's try to do that. So we have struct assign node, which is gonna have char pointer, the variable, or I guess identifier, and we also need an expression node this time. So struct expression node, and I think I don't think I want to make it the pointer. Right, so we don't have expression node yet, but that's fine. Let's not panic about it. Okay, let's do if node. The if node is gonna have two things. It's gonna have the relation expression and another instruction. Now the sad thing about this one is that it needs a pointer, so rel node is gonna be the relational thing, and I guess instruction node needs to be a pointer because it's defined before this struct, so it's not defined yet. That's the bummer. I mean, it's recursive, so that's why. Next up is struct go to node, and this one is gonna have, I guess it only needs the label, so it's gonna have a char pointer label. I don't even know if it needs to be const, but whatever. So that's just a label, and then we have output. So struct output node is gonna be, so I said you can only output a term. Okay, so it's term node. So it's struct term node term, basically, right? And the last thing is another label, so struct label node, sharp pointer label. And even though these two are the same structure, it's better to keep them separate, I think. I mean, it's gonna make it more visible. So yeah, this, you know, like union combined with an enum combined in a struct in Rust would be much easier to have this, but still works in my opinion, so why not? Okay, so we have assign. All right, we have assign, we have if. So let's do struct if node. I think I'm gonna do if underscore just to not deal with it. Then struct goto node is gonna be goto. Struct output and struct label node. Right, so we have all the instructions here. Now sure, we need to define expression, relational, and term. Right, so let's go here and define, let's define term, or I guess any could work because, you know, so let's do enum expression kind, and right now I said that expression is gonna be only plus, I guess. So struct expression node is gonna be this, and in the union we'll have, well, here I liked doing binary expression binary node as the base structure, which I think it's pretty cool. So struct expression binary node, it should have two terms, term node left hand side, term node right hand side, right? Oh, and this one is a structure. All right, so that is gonna work. Right, we have the expression node. This one stopped complaining. Right now we only have plus, but you know, I encourage you to try and add the other operations, like that, you know, would be cool to see, but you know, whatever you want. So the next one is gonna be enum relational kind less, or I guess less than, just do it like this, and I think I want to call this one term binary node. Okay, whatever. So let's copy this structure, which kind of feels the same as expression, but less than. But the difference is that you know, you can use expressions in assignment, but you cannot use the expressions in the if, and the same goes with relation. It's the other way around. So looks like the last thing that we need to define is the term node, right? So maybe it makes sense. I was thinking, what if term was actually an expression, you know? But then relational would become a bit more tricky. And you know, yeah, let's keep it separate. So we have enum term kind, and we have term input, term int, and term identifier, right? And now let's do struct term node. It's gonna have a term kind, enum term kind, obviously, and we need an union again. And what can we have in this union? So input is gonna be, won't even need union though. I think the int and the ident are both gonna be char pointers, so I can even say just this, honestly. Like term node, funnily enough, it's just a token, but only three types. So yeah, this should be the ST. Now actually parsing the ST is gonna be a bit more difficult, but let's try and do it. So struct program node parse program, and what we want to actually, let's do it an int, and let's say ds dynamic array tokens, and we want a pointer to a program. So it's gonna be something like, let's make it void, why not? Because we are gonna panic on errors, you know, let's not try to do error handling. So if it's tokens, right, and then the program. So thing is that we have couple of different things that we can parse, right, on each instruction. So what can we do in this case? Well, the first thing would be ds dynamic array. Let's initialize the program instructions with the size of this thing of instruction node. And yeah, I think I need a pointer there. Okay, so clearly we need a way to get the next token. Right, like what I remember I did in the what the fuck did I do in my parser, in this one, was that I had some utils functions for advancing and so on, which, you know, makes sense. like having parser advanced. That's pretty cool function to have. So why not just have a parser, right? Parser structure. So the parser structure is going to have a dynamic array of tokens, and I can do the same logic with int position, you know, all of that. Basically that's what I did here. But at the same time I thought that this was I mean, you know, it works, and if it works, it works, I guess. So yeah, like having the position and no, the read position. No, let's try to recreate that, right? Like, why not? Because in my own implementation I didn't do this kind of stuff, and I feel like this would have been cool to do. So we have the position, read position, and struct token tok. Right, so let's do a void parser init, and let's pass in this dynamic array of tokens and struct parser pointer p, and instead of this we can do here struct parser pointer p. Let's do this one. Oh, actually this one can go here, there, and we can say something like p tokens is equal to tokens, and sure, like fair enough, we can have these two functions of picking and reading for the parser as well. So we can have parser pick token, right? Parser but yeah, at the same time, I don't know, I thought that yeah, like here I had wasn't returning the, you know, let's make it void, why not, and return it like this. Although I mean, maybe that's why I use like index here, and I was like, okay, whatever, doesn't matter, like index is equal to 0 or p index. Okay, whatever, let's do parser current. It's gonna take in a parser and return a token, right? And what it should do is token is equal to, well, it doesn't work like that. I have to use the ds dynamic array get, right? So parser tokens, well, actually this one is interesting because this one was speak, but I'm interested only in this. Oh, and you are telling me that wait, what? Oh, I need the reference. Okay. Okay, and let's also do parser advance. So advance is just gonna do something like p index plus plus, right? Even though here I had like error checks and all of that. Whatever. Right, so basically that was the idea behind that. And yeah, this is like pretty much how I like to do the parsing. I call to current, then I check if the token type is the one that I needed, and if it is, then I advance. So that's how I did this entire thing. So yeah, but it's interesting, right? For program, we basically have a bunch of instructions. I mean, it should be similar to this, so why not? Let's initialize a token, and again we might need a do while loop, and we are gonna while it, we are gonna loop until we find end. Right, it's the same as printing basically. Okay, and in this one here it was a single kind of element in the array, but we have multiple. Here it was only class. So we actually need to take current, right? We need to take the current node from P, and we have to check. So if it's an assign, then it started with a variable. If it's an if, it started with the if token. If it's goto, it starts with goto. If it's output, it starts with output, and if it's label, it starts with a label. So that's how we can differentiate between all of these without having to do pick, right? So that's pretty cool. So if token kind is equal to ident, right? Then we have to parse ident. And I feel like I'm gonna need an instruction node somewhere here, like we did with this. So let me just do instruction node. So struct instruction node, instruction, right? And here I'm gonna do something like parse assign, and pass in the P and the reference to instruction. Why not? Right, that's my idea. And then we have to append it, append the instruction, but I think I can do that here. So I'm gonna do program instructions append instruction. Alright, something like this. And I think the advance, where should the advance happen? Should it happen? I mean, clearly we need to run something like this. There's no other way. So after maybe we finish the entire check with the if statements, we advance, we add the instruction, whatever, and then we take the current node again, or I guess the current token, because we have to check if we finished. So I think that's how we do that. Okay, so we covered the assign case. Let's cover the if case. So if token kind is equal to if, then we parse if and instruction. If the token kind is goto, so token kind is equal to goto, then we parse goto and instruction, and we should do the same thing for output and label. So let me just else if token kind is equal to output and instruction, and else if token kind is equal to label, then we parse label with p and instruction. And now what we have to do is fix these errors, and we should have the AST. But I mean, you know, it's gonna take a bit of time, but shouldn't be that difficult. And after we get the AST, we might think of either doing an interpreter or a compiler. So yeah, I'll think about it, and you know, come back to these things. So yeah, let's see how we can implement those things. So let's see how we can parse each individual thing. Now I just want to remember, well, here the thing was that, you know, I didn't like, my issue is that if I find parse assign, well, no, it's fine because I can do parse current again. I'm yeah. So let's try to do each one. So parse assign. Actually, let me just do another thing first. Okay, let's do DS panic or what? Oh, I was going what the fuck. So no, oh my god, I don't know how to type. Unexpected token. And I guess we could, honestly I don't remember how DS panic, it was logging an error, so it adds a new line. Perfect. I mean, it's not perfect, it sucks, but it is what it is. So I would say token show token kind. Well, yeah, I mean, whatever, show token kind should work. Oh, token kind. I was thinking, oh, it would be so cool to be able to, yeah, doesn't matter. Well, let's just show the token kind. I think it would be enough. So we have parse assign, right? So parse assign is gonna take in struct parser p and instruction node inster. Alright, so what should we do here? Well, first of all, let's take again the current token. So the current token is clearly known that it's what do you call it? It's an identifier. So we might as well just say instruction. We know we have an assign, so we just take the assign, and then we can say the identifier is going to be token dot value. Pretty cool, right? And then we can parser advance. So parser advance takes in the p. Right, pretty cool. We don't have to do any checks because we are sure it's an identifier. So yeah. Okay, so if we do now parser current of p and token, we need an equal. Like, if we don't find an equal, we are cooked. So token kind is not equal to equal, then we might as well just panic. Expected equal found %s to show token kind, or what? Show token kind, right? That's how I would do it. And after we found the equal, clearly we can advance. And now comes the interesting part, because we need to parse. So we need to say something like parse expression, right? Like, if we take a look at readme, we see that variable has an expression here, so we need to parse an expression, right? So we are gonna pass in the p and instruction expr. Wait, isn't it like that? Instruction, oh, assign dot expr. Now the thing is that expr is not a pointer, so we should say address here, and let's implement parse expression. Now the thing is that parse expression is not gonna work as you know, my implementation from cool compiler, mainly because, as I said, we are gonna have only two things in here, like only plus, and I'm not even sure if I want to have a single term. Like, what if we do just this to make things even simpler? I mean, it sucks, but maybe at least if I keep it like this. No, let's you know what, let's do it with plus only, right? Let's do plus only. Because you know, you can do 1 plus 0, but no, let's do term, because it's not gonna be that annoying to do. So what we have to do when we parse an expression, you know, usually you would have to make sure that it's not left recursive, so you don't cycle, you know, through the things. But in this case it's not gonna be left recursive because it's a stupid expression. So what do we have to do is have terms at this point. So struct term node left hand side, or I guess term, right? And we are gonna do something like parse term, and we pass in p and term, and then we have to do a check. We have to do a check. So we parse the term, we take something like this, the current token. If it's equal to plus, then we have a plus expression. Otherwise, so if it's a plus, we are gonna do advance and parse another term, right? So I mean, I can even call this left hand side and right hand side just for the memes, just not to worry about it. Okay, we parse the right hand side on this case, right? And then we can say expression arrow add left hand side is left hand side, expression add right hand side is equal to right hand side, something like that. I mean, you know, it's not ideal, but should do the job. And you know, if it's not a plus, then it's something else. So clearly the expression is, oh shit, expression is just a variable, so expression term. So struct, here we can have a term node if it's a term, right? So expression term is equal to left hand side basically, right? So that's how I would implement this one. And now let's do parse term, void parse term. So parser p struct term node pointer term, right? I think we need the token, right? We need to take the current token, and now we have like three cases. We have input, so then term dot kind is equal to term input, but it doesn't have any. Oh, but here I also need to say I forgot about that, expression kind. Or what? Isn't it expression kind? Expression kind is equal to expr plus. Forgot about this. And here I need to say expression term. Probably I need to go back to that one as well. But let's do this, right? So we found the input, we parsed input. We found the token kind is equal to int. Then we token kind term int, and term dot value is token dot value. And else if token kind is equal, oh my god, this almost ident, then term kind is term ident, and obviously term value is token dot value. Okay, and on the else case we ds dot panic expected a term input int or ident, but found %s, and this should be show token kind token dot kind. Perfect. So this should be parse term. Parse term is then used in here to create a plus or a term, and here you, if you want to work on minus, multiplication, division, here is where you should add them. It's pretty self-explanatory how you do it. And if you want to be even more big brain, or you know, have a 15% muscle increase instantly, like if you do that, I don't know how that was the opposite of it's over for you, bro. It's like it's over for everyone else other than you. Like if you do the like real expressions, not my pussy expression style. So yeah. Anyway, let's see. So parse assign. Okay, we parsed the expression, we parsed everything. Let's just say that the instruction kind is equal to instruction assign at the beginning. Just make things easier. So boom, we have assign. Easy. Let's do parse if. So for parse if, let's just copy paste this one, right? Parse if instruction if, right? So we can skip the first token because we know it's an if, we don't care about it. Then we want to parse a relational thing, so it's gonna be if rel, parse rel. Then we need to do something like this for the then, but do we even need then? I mean, it's cool to have it, but you know, expected then found something else. It's like it's not needed because we have relation and then expression, but at the same time, you know, it's like pretty cool. Makes the language look a bit nicer. What the fuck? Wait, it's if node. Oh, relation and instruction. Alright, so parsing. Oh, I'm cooked. I'm completely cooked, so this should be in a separate thing then. This should be in a separate thing, so I guess this entire this entire thing should be like void parse instruction. Right, yes. Okay. And parse instruction. It also needs a token here, so parse instruction clearly is gonna need p, like that's obvious, it's gonna need a p. And I feel like, so it needs a p and the instruction, so it needs this thing like this. Holy shit, this is insane. Okay, so it doesn't have that, it doesn't need all of this. Okay, and the append is not gonna happen here, it's gonna happen here, right? And I deleted the instruction because I'm stupid, and we do it here. So struct instruction node inster, just like that. So this should fix that, right? So obviously it's gonna complain that, oh, it's not defined. Well, shut up, it defined here. Let's do this. Okay, now it stopped complaining, but without the pointer. Okay, so we still have goto, output, and label, which are, these are easy. They are let's try to do a speedrun when I get to that, but first let's do relational. So let's go to expression and try to copy it. Actually, I think assign is much closer to relation, if you believe it or not. It's like relation rel node, right? It's rel node. Where the hell is it? So rel. Okay, so rel node, clearly we don't know what it is. Actually, I mean, okay, whatever, let's take these two. So we are gonna need nodes, right? Or I guess terms for this thing. Okay, we don't know what the kind is yet. Actually, yeah. So let's take a parse term, right? We need to parse the left hand side first. Then we need to take a token, right? We need to take a token. Okay, and if it's less than, we advance, we parse another term, and we say that the relational is rel less than, and on the else case, expected less than found, or I guess, you know, relational, and here is the list of possibilities. So I think it looks good. Less than. So parse relational is gonna parse a term, right? Is gonna take the current, advance, parse another term, and then set that, which looks good to me. So let's try now to do the speedrun on goto. So parse goto, and to make it more speedrunny, let's not allow us to copy stuff. So goto. Oh, I already messed up. I think it's instruction node. Instruction. So instruction kind is equal to goto, or I guess instruction goto. Okay. Yeah, clearly we need to advance because we read the go-to, and after go-to comes a label, so we can read that. So we need to do parser current, parser advance, and so on, and if it's not label, expected label found whatever, right? So that's how it goes. We advance, and that's that. Although I feel like we should also instruction go to dot label token dot value. I think we need to put this thing, right? Yeah. So then let's copy this one for output. I would also like to make this like print it curious. Instruction output advance. I don't remember output what I said. Okay, so I said, oh, we advance and then we parse term. We parse term. Let me just copy this thing for left hand side and stuff. It's just left hand side, P and LHS, and then instruction output dot term is equal to LHS. So that's output, and label is gonna be parse label. So label is gonna be just inster label inster dot value is equal to, I need to do token current, or I guess parser current. Do it here, and then obviously advance at the end. So label dot value. Oh, what? Label is a char? Label node. Oh, weird naming, but okay, I take it. So I guess this should be everything for the parse program. So start parser p, parser init should take in tokens and the address of p. And then let's do parse program. So it needs address and program node. So this should work. Should. I mean, I don't know if it's gonna work. Expected equal found ident. I wonder where. 360. So in parse assign. Huh. So in parse assign, it said that it expected equal, but it found identifier. So maybe I forgot to do advance. So parse instruction, then it came in assign, I took the current one, which is the first token identifier, then I advanced. Let me show the oh my god, printf. NII. That's interesting. Where did I fuck it up though? So this one worked, and here on this I. Oh, wait, what? Expected equal found ident. Bro, are you stupid? Maybe for output I forgot to do something. Oh my god. Maybe for output I forgot to advance oh, I forgot to advance after I read a term. I guess. Oh shit. So now it complained about the basically the first one, unexpected token equal. What the fuck? Wait, where do I handle term? So here, parse expression, relational, wait. So parse instruction, right? So probably in assign it looks like it, well, maybe not. So inside of parse assign, unexpected token equal, unexpected token equal. But it looks like it comes here, then we do all of this stuff, then we parse expression, which parses a term, right? Then it parses a term, right? Which is input basically. But I need to parser advance. Oh, you know what? I don't have to do this parser advance. For fuck's sake. Oh my god. So parse assign gives me like token value and printf %s \n show token kind token.kind, but I need to do parser current, and it should say that it's an input, right? Yeah, so it's gonna read an input here. So it's gonna do like parse term. Like what the fuck? Parse assign. Oh, I do an advance here. Maybe I shouldn't. unexpected token end. Oh, which is good, because end means that it stops. So wait, where do I have that extra thing? Extra printf. So here I have to do parser current at the end. I don't know why I deleted it. It should be here. Okay, so it ran fine. So let's see if I can do void print program. So it should be like struct program node. Okay. So it's gonna be something like for unsigned int I is equal to 0, I is smaller than program instructions count, right? We have, whoa, hell, we have to do something like struct instruction node is equal, I guess, instruction dynamic array get. Instruction, and here I need a pointer. Alright, so now I should probably do a switch instruction kind. Let's see if the LSP helps with the switch. So if we have an assign, printf assign, let's do just this at first and then break. So label output go to if, and print program. I don't know why I made it a pointer, because it's not really needed, but yeah. So we have assign, label, output, assign, and if, which is clearly what we have here. So 2 assigns, 1 label, 1 output, 1 assign, and 1 if, which is pretty amazing. Holy shit, we actually managed to get an AST quite quickly though. So okay, if we have an assign, right, what can we do with the assign? So we have assign node, ident and expression. So printf assign, I don't even know what I want to print though, like assign %s, and then on the next line maybe the expression or some stupid shit like that, but instruction assign ident break. For the go-to is pretty obvious what we are gonna print. Go-to label.label, or is it just label? Yeah, it's just label. Then we break. For output, it's also quite obvious what we are gonna print. Oh, this one is interesting. because we have a term, so here I can do another switch. Wait, what? So here we can say, you know, it's funny, printf input, printf %s new line, value. I mean, for the two of them is the same thing though. So breaks, right? And for the label, I'm gonna do label. So let's see what we see now. I'm curious. So we have assign to n, assign to I, we have the label, output I, assign I, and an if. Okay, here should be switch inster assign expression kind. So yeah, and in case we have a term, there's gonna be a break. So in case it's a term, it's probably gonna be the same thing as this. Another switch. Right, and if it's a plus, holy shit, it's the same thing again. I mean, you know, it's not ideal, but let's say expression left hand side, right hand side. So I mean, it's not ideal because I can do it recursively and stuff, so oh no, oh fuck, oh, because I have to use this kind of stuff in here. Well, fuck, let's do void print term struct term node term, and let's do something like this because it's you know, it's not ideal to do that. So here it should be just print term inster sign expression term. Wait, once a pointer, but yeah, whatever. And if it's a plus, then we do pretty much the same thing, but for left hand side, right hand side. So yeah, that's how you do assign. And then we have another thing here, like print term for the output term, why not? Okay, so we have assign input. So assign to n we assign input, to I we assign 0, label output I. Here we assign, you know, I plus I. So I can even say here print f plus new line stuff. So it's gonna say, yeah, so assign input to n, 0 to I, label, output, then we have assign, and here it's missing something. Oopsie doopsie. Whoopsie doopsie. Let me do here like switch. What am I doing? Okay, so this one has a single case, so I need to print both terms. So instruction if rel less than, right, I is less than n. Maybe I didn't oopsie doopsie here and it doesn't print the number or some shit like that. I have to check it because here I thought it says int 1, so it should exist there, but I don't know what happened. Like what? Because that's like value. It's really strange. Okay, anyway, let's see. So this is print program. I should do print instruction because of this. Print instruction. Right, and here call to something like I mean, this still works, which is nice. And for the if, I can do then print instruction if dot inster. Alright, and I mean, yeah, sure, whatever. Oops, it has to be dereferenced. Why not? Right, so go to label. So this one works, but I don't know why the if statement doesn't work. That's a bit strange. Huh. Or I meant the plus. So print term. Doing it correctly, right? So print f show token kind inster assign expression add right hand side dot kind. Kind is not even correct. It's term kind. So I should do like d. Okay. Wait, what? So it's a one type, right? So yeah, it's int. Let me put some ticks around it. It's empty, what the fuck? Did what? Like literally when I create the the instruction. Maybe I'm doing something stupid, but I'm not. Let me just do like some stuff just to see it. So we GCC it and see it's a 1. The fuck? So right hand side is gonna be that thing. Okay, this is strange. Really strange. Because I can see that we assign something to it. So then why it's not a value here? The fuck? Like I don't see it mattering. Like, let's say I put it like this because I don't know, I'm like annoying or something. Like still doesn't work. The fuck? Oh, this is for rel. I meant for this one. Like what would happen if I put it like this instead? Nothing really. But this is weird. Print f %s. Like what? Doesn't help if I don't know which print it is. Yeah, so it's a 1. Parse expression. Wait, what? It doesn't make any sense. Why is this thing so cooked? So it's like add left hand side. What the fuck? Must be something with the size of the dynamic array. That would be really annoying. So relational expression node. But it cannot be. No, like if I don't use union, let's say. Yeah, I mean, you know what, fuck the unions. They are useless. I mean, I'm just kidding. But yeah, like maybe it's an issue with the size in the array and somehow it breaks. So yeah, but now it looks like it is indeed working. Oh shit, it's not. Wait, what? It's really strange that, okay, I removed it from there, right? And it's fine. But if I remove it from the other places, it crashes. Bro, I mean, this is C for you, basically. Oh my god, what the fuck, now it's... No, it's the first one that's not shown. Oh my god. But I'm really surprised that if I remove unions, it just segfaults. Like, what the fuck? Literally makes no sense why it would segfault. You know, we could maybe valgrind just to see where the thing happens, but when we compile, we should compile with -G, right, for symbols or something. So 388. Or 338? Wait, no, 388. Ah, damn it. But yeah, I don't get it. Like, so what? It's uninitialized. Go to... Yeah, like, why does it matter? .507, there's also an issue. So in the list of instructions, well, I mean, easy fix would be to say is equal to 0. But I thought, oh yeah, because parse program doesn't initialize it. Okay, then maybe I forgot to initialize it with 0 or something. Still fucking segfaults. Oh my god. DS dynamic reinit. So at 507 it crashes, which is quite interesting, because in parse program we initialize that. It's so fucking weird. And I mean, you can say that I initialized it with 0 as well. So what the hell? What? Why would it not work there? But maybe it's related to the other ones, like 379. But I don't get why instruction go to complaints. I mean, that's the one from the if. That's the one from the if statement. What I don't remember if I need to allocate this thing. Do I need to allocate it? Honestly, I don't remember. Oh, it just needs to allocate that shit. Okay. Okay, so now it works. So does that mean that the union was still fine then? Let's go back to using unions, right? But when I do the if, where the fuck is the if? Okay, here. I also malloc size of instruction node. Okay, so now it works. Yeah, you just have to be careful and allocate when you need to allocate. So basically we also have the AST now, so we are pretty close to being done because we don't do any type checking, and type checking is the one that takes the most time. So yeah, basically we have assign, see, like assign and an input, assign I0, we have the label, we have an output, we have another assign, and we have the if statement. So if the condition and the instruction. So we can parse the thing. All that we have left to do is to actually use these things, use these structures to run the program. And yeah, now I have to think if I want to do interpreter or compiler, but yeah, we'll have to see. And it's also like under 500 lines of code, which is pretty cool. I mean, it's 550 almost, so we'll see if we can manage to do it in under 1000 lines. That would be amazing. But yeah, so let's see what we can do with the assembly now. Alright, so we left off at like building the AST, right? So we have the AST, and now would be maybe a good idea to create some assembly from the AST, like imagining that there are no semantic errors basically. And I guess another good thing is that since these expressions are like only two terms, it should be pretty easy to convert them to assembly, because you know it's the sum between two things. So yeah, I mean, you know, I guess would be easier if we would restrict these to be only variables, but at the same time wouldn't really work. So yeah, like say that this and this is only variables, but I feel like you need to use literals. Okay, anyway, so let's see how we can do that. So ideally we'll have something like print program, right? We have to go through all of our instructions and generate the assembly for each instruction. That's the idea, that's the main idea. So program assembly, this one needs to take in a program node, so program, and then we have to do a for loop. Basically it's the same thing as this one. Let's say, alright, so it's the same thing. Alright, we iterate everything, and instead of print instruction, we can do instruction assembly. Okay, so let's see how instruction will look like. So it's gonna take in an instruction node pointer instruction, I guess. Doesn't matter if it's a pointer, I would rather have it as a pointer. Okay, so now we have to do a switch over the kind. So it might be a good idea to just copy paste this entire thing, like the body of the function, right? And paste it in here. So it's gonna be instruction arrow kind, and then for all of these we have to implement the stuff, basically. Okay, so obviously the label is gonna be the easiest one because it's gonna be just a label, so we can actually have that. So what I'm gonna do is just use printf and that's it. Let's not waste time with formatting stuff. It's just gonna be the label. So we do %s new line and then instruction label. So this is gonna put the label down. I think I need, oh yeah, and for the assembly I think I'm gonna use FASM syntax. So I think it's the easiest. What? Where is dark reader off? Although I don't think it matters. So, but yeah, let's use FASM. So instruction output, we are gonna write these things by hand, right? So we are gonna call to them, but we'll see how the thing will look like. The other one that's easy is gonna be go to. So this one is gonna be just jump to the label, and okay, fine, I would put 4 spaces in front of these kind of instructions and keep this one aligned like that. I think I prefer it that way, but other than that, let's not waste too much time with this, right? So go to label, right? So the label is what is it? Okay, perfect. So now we have go-tos and labels. That's pretty sad. It's the only thing that we can have. Okay, fair enough. Though we also have instructions. Oh, and another thing that we need to do is to count how many variables do we have, because we need to allocate them on the stack, right? Like if you think about it, if we take a look at the example, we have variable n, variable I, and that's it, right? We have 2 variables on the stack, so we have to allocate them. Now the good thing about this kind of program is that we don't have functions, we don't have like declaring variables and stuff, everything is gonna be declared basically. I guess that's how I want to do it. So we don't have scopes, I mean. Okay, whatever. Right, so we need to know the name of the variables that we use. So let me do a program assembly. And I guess, you know, in program assembly we are gonna count the number of variables. So and I'm even wondering, let's have an array. So ds dynamic array variables. I have to use struct. I don't remember, honestly. I don't know though. Let's keep it like this. Write variables. So this one is dynamic array init. Let's put the address of variables and the size of char pointer. So we are gonna hold all the variables in this array. Okay, fair enough. So I would say that in this function we need another for loop, obviously, over the instructions, and I guess it's gonna be something like instruction declare, like declare variables, and we pass in the instruction and the variables array. I think this is how I want to do it. And then void declare Mr. declare variable, I guess variables, right? Struct instr node pointer instruction and ds dynamic array pointer variables. All right. So, oh shit, another switch. But in the switch, pretty sure that we'll have to do the following thing. Wait, it's instruction assign. So obviously for assign, we have a variable, right? So but we first have to check the expression. So we have to say something like maybe expression declare variables instruction arrow assign dot expr. Right, we need to say here like this. Oh, and maybe this one is like, we still need to do some kind of type checking, but we just need to check that all the variables are defined basically, right? Because we cannot use them if they're not defined. So yeah, it is what it is. So we do expression declare variables, right? And we need to pass in variables. So this is going to be for expressions. Okay, expression node. All right, so for expression node we have here like pretty sure there was like oh yeah, this one, the switch on this thing or something like that. So where is it? Okay, here. So expression kind, right? And we want to check like term declare variables, right? So if it's a single term, then we have term, right? And variables. And in this one we need to do add left hand side. Actually it's dot, but yeah. And right hand side. So now we also need term declare variables. Okay. Alright. So this one probably is gonna be the address, because why not? So this is term. And as for this one, one second, I have to put it, wait, where is it? It's here. So if we have input, then we don't care about it. If we have an int, we don't care about it either. But if it's an identifier, this one is gonna be interesting though. Because yeah, I want to just to type check that the variable is inside, right? That's the thing that we have to do. So here we type check that all the variables are inside, and I guess we define them. Okay, yeah. So I have to do something like is this dynamic array, I don't have contains, so it is what it is, for unsigned int I is equal to 0, I is less than variables count I plus plus, right? And I guess that if, wait, what? If no, I have to get it. So it's gonna be char pointer items or variable ds dynamic array get, and here we pass variables. The index is I and the item is pointer to variables, right? And then oops, if a string compare between term value and variable is equal to 0, so if we found it, then we can just return because everything was fine. But if we didn't find it, we can just panic and like something like we don't care about the, so the variable identifier is not defined, and then we can say like term value or something. Okay, and I need this. So yeah, so basically if we find the variable, then it's fine, but if we don't find it, then you know, it's cooked. So let's remove the printing though, because I don't want to print anymore, like everything works. Sample txt. Okay, and let's try to run this thing. So cat identifier is not defined I, which is not really true. Oh yeah, but we haven't gotten to that point. So it works basically, as you can see, it works because we forgot to actually add the variable in here. So after we declare the variables, right? After we declare the variables, we have to say something like ds dynamic array append, and I need to append an item, so it's gonna be in the address to instruction ident, hopefully. Oh, and I also need the variables. Yeah, so now we added the identifier, so we shouldn't see the error anymore, but we get segmentation fault. Why is that though? Curious val grind, curious situation. So it's at 556. Okay, yeah, this one sucks, but like I don't know how well, I mean, I don't know, it's my library and I'm not able to use the dynamic array. That's funny. Yikes. So yeah, it's fucked, right? What's put inside here? Wait, where is it? Like here, when I append the ident, it's bad. So maybe I shouldn't put the address of that. I don't know though. It doesn't fucking work. What? So append gets a const void pointer. So void pointer is like the item. So it should be the address. I don't get it. So ident is a char pointer. So if my items are char pointers, I have to put the address of the char pointer here. That makes sense, right? That makes complete sense. But when I take the value, I'm even getting annoyed by print program and everything, so I'll just remove it because it's like completely useless. So here, right, I have a char pointer. This one represents like the thing, and here I know that. Okay, this is weird. Variable is equal to null, but shouldn't matter. This thing takes in a pointer to that, so maybe it's not even this, it's like that. It doesn't make sense though, because yeah, it's gonna crash. So what the fuck? So here I mem copy that address, so I take from that plus item size, and I mem copy item size into it. So yeah, it should be like this. But then why doesn't it work? So if I print the pointer, holy shit, what? Wait, what? Wait, that's weird. That's really weird. Wait, but then what does append do? So append should also mem copy. So it mem copies from item. So yeah, and if I pass in a pointer to a string, it should be the start of the string, which it's put inside of this thing. So like literally I should see, but I don't get why I don't see the following thing. So it should be something like this. Right, oh, it's the same address, but why is it twice? Wait, what? Wait, what the fuck, why is it twice? Bruh. See, this is why I don't like C, because of the strings stuff. It's like, bruh, the fuck. Like, it would be much faster to do it in like simpler, a language that has better strings, I would say. Like maybe there's, that's where Zig is better, right? Because you don't have to deal with all of this crap. But at the same time, you know, you shouldn't have these problems. Like with enough experience you'll not have the problems, but yeah. But I literally cannot think why this happens. So what I'm gonna try to do is get ref, and get ref just gives me the thing like that. But for this thing I need to use a double pointer. Wait, I need to use a double pointer. Wait, what? Oh my god, is variable here. No wonder it wasn't working. Okay, so yeah, whatever. That's funny. I mean, you know, I was like, oh, why doesn't it work? So N and Y, right? That looks good. But why do I see label twice? That's strange. Because I only have one label. That's really weird. But anyway, we declare the variables, right? So we check everything. Let's go in example and try to say like plus B or something. Let's see if it finds that B is not defined. Pretty cool. Okay. Now sure, it's gonna have NY, NII, right? Like whatever, doesn't matter. It's important to have the variables in an array, right? So if we do a for loop now, okay, let me take the for loop from here because it's easier. Just copy paste this one. So I'm gonna do like this and reference, and here let's just printf the variable. So like this, backslash n variable. So we should see NII or something like that. Yeah. yeah, sucks that we have duplicates, but shouldn't matter. Wait, but why do I print that thing again? So let's see. So instruction declare variable, right? We find a sign, that's the only thing that matters. Well, if we find an if, then we should do something like rel declare variables, and we should pass probably like instruction if rel variable. So this one should check that, you know, you have defined your thing, and inster declare variables, and sure, here we should pass if, which I think this one is already a pointer, so it's fine, and the variables, fair enough. Okay, if it's a go, we don't do anything. If it's output, I feel like we should probably term declare variables, and here pass instruction output dot term. Right, I think this is fine, and the label doesn't matter, so like that. And if we go to expression, we can just reuse this one for relational expressions. Whoa, that's cool. Okay, and this one is gonna be rel node, rel less than, and less than. Perfect. So this should check everything now. Okay, and if we rerun it, we see the label once because that's how it looks. And if we go to example and say something like b instead of n, let's say, let's rerun it, it's gonna complain about that, right? So everything seems to be working correctly. Alright, so we declared the variables, we checked that all the variables are defined, so the next logical step is to continue with the assembly. So let's go into instruction asm. So far we handled instruction go to and instruction label. Let's see how we can handle maybe the if. So, an example, for the if we have like a condition and a go to. So maybe a good point would be to check cool compiler, the assembler from. Interesting. I don't know what the fuck this one's, but whatever. So I guess assembler, right? And here when I did the if expression, I guess I called it emit if cond. I don't remember how I called it. But would be really useful to see how I did the assembly there, if I can find it. Maybe this one, jump if true, right? Whatever, so let's try to, but you know, I didn't want this one, I wanted like if true or something, if I have it. Emit tree address code jump. Okay, so we should do something like test and jump not 0 or something. But first we need to compute holy shit. We would need to compute the result, so maybe it's easier to just do the assign first because it's an addition. Well, I guess the actual first thing that we have to do is to allocate the variables, right? So after we declared everything, we should probably do subtract. So it's pretty similar to what I did where would that be in the old code? Like, just to make a comparison, should be somewhere where I defined methods or emit expression, because you'd have to just subtract from RBP. But I mean, maybe it's easier to just check, for example, the assembly itself. So if we look at prelude, for example, and we look at the assembly, we should see something like subtract from RSP and then 8 times the number of variables. So maybe that's what I want to do. Right, so print f, and as before, 1 2 3 4, right? And we want to subtract from RSP %d, and we want to subtract variables dot count times 8. Alright, so that's what we do. I don't think we care about anything else, so let's just leave it. And at the end, obviously we need to add that back. Although, is that really needed? Because we exit anyway, so why would we care? But anyway, let's keep it. So we subtract this, right? I guess also have the entry point would be a good idea. Although, yeah, I don't know. Like, maybe having the entry point could be a good idea. So, but I'll see. I just want to get the basics going. So here we declare our variables, and that's that basically. So now we know how to access variables, right? So we search into the variables array. That maybe means that I need to pass in variables here as well. So variables. Oh, but here it starts to suck. Yeah, no, I have to keep, like, if the variable already exists, I have to not insert it. So let's just do it like that. So if it exists, then we don't do anything. Right, so makes more sense like that. So I'll do it at the end, and here we have to return actually. So I'll do a for loop over the variables, right, like this, and we have to compare instruction assign identifier. If it's equal, we just exit because we don't want to add the variable. So now if we try and check, well, actually let me just put here array pointer variables just to make sure that it doesn't crash. We should see 16 on the sub because there's 2 variables. I mean, I'm too lazy to show them, but you know what I mean, it's like 2 variables. Okay, So now let's go back to this thing. Okay, let's try to think of how can we implement a sign, right? So we need to check. Well, actually it's not that complicated. We just need to check the expression. So probably we'll have like expression something. So like here is gonna be expression assembly instruction. Okay, assign dot expression, something like this, and variables, because we need the context. And now comes the interesting part. I would say that the result of all the expressions are going to be in EAX, so in the A register, right? And what we need to do, well, I need a function, so it's going to be something like find the variable, and this one takes in the array variables, and we have a for loop. Let me just find the for loop like this. Oopsie doopsie, so right here, and char pointer variable, or I guess identifier. And here we return I, return -1 or something like that. Okay, so now it's easier to find variable because you know. Okay, so here let's imagine that the result is in rocks, so in the A register. Well, we can do something like int index is equal to find variable. We pass the variables and instruction assign identifier. Right, so we have the index in the stack where we have to save this thing. But sure, let's not do that first. Let's just print f %d index. Let's see what the index has to say. So it's 0 1 1, and honestly it looks good because it's like first, second and third, so it's 0 1 1. That looks good. So that means that index 0 is the first one, so I would do something like, here we need to do a move. So let's think about it. Move. Okay, one more. Let's think about it. So let me check in my old assembly. So I would do keyword minus something, right? Like this. So we would move a keyword in RBP. Oh, so maybe move RBP RSP before we sub makes sense. Right, maybe this thing also makes sense. So print f, move RBP RSP, a new line as well, just to have it. And I mean, I don't care about the rest. I don't even care about the last one. So okay, anyway, let's see. So we move a keyword at RBP minus, and log 0, what's it? Log 0 is 8. So minus %d rex \n, let's say new line, and here we should do probably index plus 8 question mark, index plus 8 index times 8 plus 8. That's close, but not quite. So see, like here we save the variable, here we save the other variable, and also here we save the variable. So that's my idea. Okay, so we just have to figure out how to do expressions. That's easy. Then go to is simple, and now let's try to think for the if statement. So the if statement, it has something similar. We are gonna have to do something like rel assembly, which I kind of wait, what? Kind of want to it's easier to just say the result is in rocks again. So I think that's what I want to have. Like whatever the relational operation is here, the result is going to be in RAX. Simple as that. Okay, I guess I lost the part with the test, but ideally we would do something like printf test RAX, right? New line, and that's it for testing it. Now what's interesting? What's gonna be interesting is that we need to do a jump. So I also need to know how many ifs we had already. Well, it's gonna be just if count is equal to 0, and you'll understand why we need the if count pointer here. So int pointer if count, because basically we want to count how many ifs we have, because usually an if statement requires labels, and the labels are other labels than the ones that we put here. So that's the main reason. So let me just go back to this thing, right? Well, holy shit, it's like test, right? So it's jump not 0. So printf jump not 0, and we have to use a label here, and I like this label with the dot, I think. Well, maybe that makes sense, like the labels are gonna have dots just because the labels with dots are like local, so they are not gonna influence anything. So let's do a label, and the label should be I guess the if case, or I don't know. Let me just think about it. So probably do a D here, and we can do like, can I do if count plus plus or something stupid like this? Hopefully I can. Oh, I forgot about the new line, but that's not important. So what's more important is, so test rex. Damn, I don't remember what it does. Is it like 0 if you... But here is like jump not 0. Okay, let's try to look at how some tree address code looks like, because I feel like that's important. So the if statement, where's the if? So it's like, that's what? Branch through L0. Okay, so I have something like fall through if it's the else, and if it's the then, you jump to it, and this one jumps to the end. Okay, so I get it. So here we jump to the if basically, or like then, right? We jump to the then. Okay, we do some stuff, and then we need another label for the end of the if. So if count like this plus plus isn't the best. Let's just put it that way. So it's then, right? It's then. Otherwise would be the else case, but we don't have an else case. Okay, so we don't have an else case. We only have... Well, then if we don't have an else case, we can say jump 0 and if or something, and that's that. And then here we have the expression, and then we have printf and if. Right, so yeah, here we need to do like expression assembly, or like it's instruction, right? It's actually instruction. And we don't have a result because instructions don't have results, but that's the idea here. So I think that's how I want to do it. Okay, interesting. So it's gonna be something like this, and if, oh, I forgot about the %d pointer if count. Oh, and you know what's gonna suck? Well, actually I know how to do it. So label is pointer if count plus plus. I have to do it like this, and the idea is that if we have nested ifs, this could mess up each other. So yeah, but yeah, basically we'll have something like test rex, jump 0 is gonna jump to the end, and between this thing and this thing we should have the then expression or instruction, whatever. Okay, so this one, instruction asm, should work with if count, like shouldn't have any issues. So yeah, basically here we test it. If it's 0 we jump at the end, if it's not we jump at label, right? Pretty cool, I would say. I mean, imagine someone naming their thing and if 0, mother suckers. So yeah, so we only have to do expression assembly. Holy shit. Let's try to implement it. So expression asm should take in expr node expr dynamic array variables, and this thing doesn't really need the number of ifs because like it's not gonna require anything special. So let's see. Damn it. So expression assembly. So if it's a simple term, then we need to do term asm, right? Then we need to do something like term asm. Here it's gonna be interesting. We need to move 1, 2, 3, 4, I guess. We need to move the result that's in RAX into something else like RCX, for example, or RDX, RX, right? Like this one is also gonna result in RUX, right? So that's the idea. We store it in RAX, and then we have to do printf add RX RDX, and I think that should, I don't remember exactly 100%, emit. Dude, really, I don't get it. Where was the thing? It really bothers me that I don't find the addition. But anyway, add, like, should be. Oh, it's here. RDI. Okay, yeah, so it's like destination and then source, and the destination is used both as source and as destination. Perfect. So this should do it for the addition, and you can imagine that sub, mul, I mean, you know how it is. And then term asm. So for the term, let's try to do term node pointer term variables. Right, let's see. So for the terms, we have some stuff, right? We have some stuff. Now again, input, I'm not doing it yet. Let's keep them at the end. Input and output, they are the last things, right? So if we have an integer, this is gonna be interesting. We just do printf move. Oh, we move into RAX because we said that we move into RAX. We move, and we have to print it as a string though, which is funny. It's the immediate value, right? So it's term.value. Pretty cool. And for the other one, we need to compute the index. So let's see, where's the index? Like an example. I just need an example. So, oh, it's here. Perfect. So I need the example. Alright, so here is term value, the name of the thing. Okay, we need some kind of extra stuff. Okay. So we get the index, and we need to load the variable from the memory. So we need to move into, now we have to do the other way around. So move into RAX, keyword from there, from here, I mean. So this is how we load the variable. And yeah, this is like just loading the variable because that's that. We don't have reference to it. but when we assign, then it's when we write to it. So I mean, you get the point. Here we load the variable, here we write the variable. Okay, anyway, so I think this should do it for terms. The last thing that we have to do is the relational assembly. So let's see if everything, so it looks decent right now. We have like here we store the variable, the first one. Yeah, whatever. Then we put a 0 here because initializing that thing, whatever. Here we have like a label which was loading the variable, was putting a 1 in the immediate value, was adding the two values, saving the variable, and then running like this thing again. So we have to do the relational declare, or I guess relational assembly. This is the more difficult one, I would say. Awesome. So we need a rel, right? Oh, it's a pointer, right? So what do we have to do here? So if we have less than, we need to term assembly the left hand side, then again we store it in RDX, and then we term assign the other one, and I'd say this is like rel left less than oh, pretty clean, I would say. Now I want to see something like less than, if I did something like that, lt, and it's so hard to find stuff in this code base. I mean, I'm just like shoot, because I don't really remember. Tag assign lt. I just wanted to see how I was comparing stuff. So cmp rdirx, something like this. I was comparing it, right? So let's just look at the code. So I did cmp, then set l, and then end. What the fuck does that is this doing? I have no idea. And then I was doing a move 0 extended into Rx, which makes sense. So compare RDI Rex, set L. Well, I mean, here I was moving it into RDI, so here it's RDX, but I guess this is exactly what we have to do, if you believe it or not. It's like comparing the first one with the second one, right? Then we need to set less, I think it's like less than flag or something. Then if we end it with 1, it's bitwise ending with 1, just to make sure that we have only like 1, right? And then we 0 extend it so that it fits into Rx. So that's it. So at the end of this this relasm will have into Rx will have the value, right? And that's what we wanted for this one. So test Rx. So if we take a look now at this thing, oh, I don't want those I mean, it's cool to have the spaces, oops, but I mean, since I haven't tried to add them, let's not worry about it. I mean, it's just to show how much more complicated the cool compiler was. Like you just have to think about it. Like it was insanely difficult to complete. Like just look at how many lines this file has, 1500, and how many lines this crap has, 600. Like, you know, the difference. I mean, the entire compiler is 600 lines, right? So, and here only the assembler is 1500. So, but like, yeah, sure, formatting is not a huge thing. Like, it was just that it has a lot more instructions and expressions and all of that stuff that needed to be converted to assembly. Although, you know, I used that intermediate representation, and that's really important to do in compilers. Like, you have to use an intermediate representation, otherwise you are cooked. Like, this one is really simple. Like, if you check the example, it's really simple, so it looks really similar to an intermediate representation. That's how I designed this tutorial language, because if it was like a C style language, then there's no way you can convert the AST directly into assembly, or at least it's too hard. Like, when I had the homework to do that thing, I just gave up on it because it was way too hard. But if I knew that it's possible to have some intermediate representation, maybe I would have solved it, who knows. But I mean, you know, a couple of years later, and I actually managed to solve it. So let's see. I mean, I would yeah, like I'd like to have the code for printing numbers, but can I get it though? Let's check the lib prelude. Like, I just need to string from int to int. I just need something like string to int. I mean, I have byte to string, but it's maybe we should follow the brainfuck logic, and printing a number just prints it, but that's scuffed. Like, prints the hg value, but that's a bit meh in my opinion. So I have the BF compiler, right, which I did in both C and Zig, just to see that, like, the difference. But, you know, like, being a total noob at Zig, I couldn't I just programmed in Zig like I would in C, because, you know, that's what I heard. Like, Zig is a replacement for C, so in my brain is like, okay, then okay, so output, generate assembly for output. Let's see how I did this one, because I don't remember. So it's syscall for write, std out, pointer to current cell. Interesting, and completely useless. Yeah, I mean, whatever. I mean, sure, we could use GDB. So let's try to use GDB. Good. Let's do the entry point. So section whatever. So I need this kind of stuff, right? In the program asm. Okay, so we don't need anything from here. We don't need that. We just need this thing at the end. So print f. Let me just, no, because sure, let's just at least this part, let's do it. But I'd say that, I mean, like if this works, I'm extremely happy. But obviously I still want to do the input and output functions, like that. Those are clearly useful. Printf. Alright, so if we, this thing, I mean, it looks like an executable. Let's check the cool compiler. Examples, hello world, and if I do asm, then we get an entire piece of crap. I wanted to see, holy shit, it's so long. Well, I think it's easier to just redirect it into hello.asm. So it has this thing at the top, section text executable. Format elf64. So printf and run and so on. So let's try to say example.asm and then fasm. Damn it. Section text executable. Okay, let's check again. So section, wait, where's the start? Wait, why doesn't it, oh, I forgot to compile it. So gcc. So now it has the elf64. Sub RSP 16. What? Wait, I'm confused. Oh, I forgot the commas. That's funny. For some reason I didn't put a comma here or here. Although that's strange, but whatever. Maybe I had a... Yo, what the fuck? Example? Oh, I don't know how it's called. It's example.o, but I have to link it. Okay, let's first file it. Let's see it. It's an elf64. It runs. Holy shit. Example. I think my stuff is broken. Anyway, it's like, who cares? Break start. Run. Oh my god, it's so annoying that my stuff broke. Piece of shit. Maybe it's because I have to run it. Huh. Yeah, like I think my stuff broke. Right, like GDB peda or what's it called? God fucking damn it. Well, I mean, it is what it is. Pretty hard to debug without because I'm a bad, you know. Oof. I don't remember how you check this kind of stuff. Yeah, no, I cannot do it. Literally, it's disgusting. Maybe I have to check updates or something. I mean, I'll try to do some updates and see if I can figure out how to fix GDB, because that's annoying. I haven't used GDB in like a month or something, so that's maybe the reason. So, you know how it is with Arch. I mean, I'm just kidding. It's like the first time something like this happens, so pretty weird. Okay, so still doesn't work, but what I think I'm gonna do for like making things easy with the strings is I remember I saw this assembly example from Tsoding about like it was like creating the, I think like a web app in assembly. So and it was using Phasm. So I'll take the utils.inc file, because I was also searching on Stack Overflow and I found the exact same thing. I mean, pretty much this is also what I implemented in Cool Compiler, but I changed it because I wanted, so if we take a look at the library, so lib, let's say at should be in prelude and prelude.cl. I think that the toString function, I managed to implement it in the language itself, which is pretty cool, right? So toString, yeah, see, like it was, yeah, pretty weird. My font broke for some reason, or I guess the browser broke. Let me just reopen it. Oh yeah, it was broken for some reason. Yeah, sure, whatever. But yeah, I managed to implement this toString function in the language itself, so I didn't need this one anymore. But yeah, let's take the file, so we can just go ahead and double get it, right? And let's see if we recompile everything, if stuff is going to work. So we have to rerun this thing and then Phasm the example. So it doesn't like this thing, right? What the fuck? Okay, let's see what this thing wanted. I mean, it says Phasm. Maybe I missed something. Segment readable executable. Maybe I missed something. Oh, maybe it has some functions here or something, like right. Huh. Well, yeah, maybe it's in Linux.inc. So let's also use that one then. Sure, why not? I mean, let's try it. Linux, and let's do Linux.inc. Let's not write all the assembly from scratch, because that's annoying. So we do all the steps. Okay, and if we, I mean, it won't do anything right now, but in in output we should be able to well, not this one, but the one from insta assembly here, we should be able to actually call to that function. So that function is in util.inc and it's write uint, and it says that RDI is the file descriptor and RSI is the int, right? So we have to do a couple we have to do a few things. First we need to take the index of the variable, right? We have to take the index, and the variable is output dot term. Oh shit, we actually have to term assembly, so we have to term asm this thing, and in so variables, and now in rex, right, we should, what the fuck do I want? Okay, yeah. We should have in rex the result, which I think is gonna be, I mean, if it's gonna be a variable, what do we have in, I forgot already. Oh, it's the value of the variable, perfect. So printf, okay, so here it says RDI is the file descriptor, so let's do another one, move RDI, I think 1 is the right file descriptor, we'll see if it's the right one, and in RSI we need to put RX, and then write uint, new line. Right. I think this is all, right, uint. So we recompile the thing, we recompile that, and phasm. Holy moly, it wrote something. I mean, honestly, it's impressive already. It's already impressive, to be honest. Is this scuffed maybe? Wait, 1 second. Example.txt. So if let's go the other way around. Oh, n is gonna be 0. Let's do n is equal to 10. Oh my god, I'm the god coder himself. I'm just kidding, dude. Holy shit though. But bruh, we actually managed to finish the compiler. That's insane. What the actual fuck? Anyway, let's do the input now, because that's the other thing that we have to do. So probably we'll need this. Right, so let me find, it's here. Let's do something like this. Move this bh inside, and let's go to util again. So it's like write whatever. I need something like read, so parse uint. Well, I mean, was hoping for something easier, honestly, but this one's fine as well. Like reading, like parse uint, right? Maybe inside of Linux we have read. Oh, we have read. So read, file descriptor, buffer, and count. you know what, let me check wait to do assembly. Let's see if we see any reads. Yo, we see read. Perfect. That's fucking perfect. Okay. So let's do this, right? Printf. Yeah, because usually when I write FASM code, I don't use macros and stuff. So for me, it's like, whoa, pretty cool. So let's say line. I don't know what request cap is. Line max. So this is how you would read inside of this thing. Alright, this is how you would read inside of the line from std in. And if we go to utils and take a look again at read uint or like parse uint, whatever, it wants, wait, where does it return it? In RAX? Probably. So RDI is the buffer. So printf move RDI line, probably. Like that's what I think. Parse unit. I need to see it. Oh, you can do stuff like that. I mean, you know, whatever. I'm not that advanced at assembly. So it's RSI is gonna be the second argument. So it's the size. What the fuck is the size? Request length. Wait, why do you need the size though? Huh. Really hate this one. I need to do strlen on it. Yikes. Maybe I need to do strlen. So RDI, right? RDI and it returns in. Okay. So I do printf call strlen. So now I have in RAX I have the length, so I have to move it in RSI so that it's I don't know, hopefully that's fine. And now printf call parse uint or something. Let's see. Okay, I mean it complains obviously, so I did an oopsie doopsie. Undefined line. Okay, perfect. So it wants line and line max. So let's give that to him or it, whatever. Segment readable writable. So let's add that. So I'll have it here at the bottom. Segment readable writable. Why the fuck not? So we'll have something like this, like right, printf request, but for us it's a line. And what is request cap? It's some number. So it's also defined like this. So it's like line max is gonna be some humongous number. I mean, it can actually be whatever, but it can be like 124. Like, come on. Let's see. Still doesn't like something. Undefined symbol. Okay, so it wants, okay, probably it wants it here then. Interesting. Oh, what the hell? Oh shit. 4. Holy shit, dude. Oh my god, it just works. Bro, what? I mean, I would maybe also add a new line after each print. But other than that, holy shit, dude, we have like a compiled language in less than 700 lines of code. What the fuck? I mean, sure, it's clearly not complete. It misses like subtracts, multiplication, but those are really easy to add. So I really, encourage you to take this code and try to add, subtract, at least subtract or something. Maybe even like if you go up here, I mean, you'll see what tokens are available, but maybe you can even add like less than equal, for example, like in these things right here, right? Or even, if you want to be a giga chad, you can add like real math expressions, not these really simple ones, but dude, it's actually like working. Sure, it's it's really scuffed, but it just works, right? We got a running program which prints numbers from 0 to n. So yeah, I mean, hopefully you find this one useful. I mean, it's a really, how can you say that, like, distilled version of the full compiler that I did. So it has a bit of everything in it, but it's not something useful. It's just a language to learn how to build a compiler. So this is what I would expect a beginner to try and do as the first project for a compiler, and only after you get the experience of doing this thing, then I'd say you can go and do your own thing, because otherwise, I mean, even better would be to write your own assembly like this, but I'm too lazy to do that, and the video is extremely long already. So yeah, like that's pretty much all. So we have labels and stuff. So let's try to do something else. Like if I is smaller than 10, then go to label 2, let's say label 2, and here output 69. So if I is gonna be okay, let's see. So if I run example and I put like 4, is gonna say, I'm not gonna say 69, but if I say 50, it's gonna say 69 at the end. So I mean, yeah, like first, and it was also first try. Like, you have to think about that. I mean, sure, it was the thing with GDB. It's not working anymore. I don't know why. Doesn't matter. I don't use GDB anyways. I'm a printf debugger. But in a scenario like this, GDB is good because you cannot printf debug this crap. Anyway, but it was pretty much first try everything. Like, if you think about it, first try for almost everything. So yeah, I mean, I don't know, like, pretty cool, right? Anyway, so we actually managed to implement a compiler from scratch in one sitting. Like, that's pretty cool. Sure, I mean, would have been way cooler if this was like a stream, like interactive, but I think I would have been too distracted to actually finish it in one go, so probably it's better like this. But yeah, I mean, again, hopefully you'll find this one interesting, and you know, like the video, share it with your friends who don't know how to write compilers. Maybe they'll start to learn how to write compilers, and you know, feedback is appreciated. So yeah, but see you on the next programming section. So see you.